So if you can put my, yeah, thank you.
Maybe we can dim the light a little bit.
John, thank you so very much. Since you brought up my 1975 paper on climate change, I worked on this for almost 4 decades, but my idea of the nature of the climate change problem and the human dimensions of it changed dramatically after I was fortunate to be elected to this academy 10 years ago. And so that's what I'm going to emphasize today. First, I had the privilege of helping our Chancellor, Marcelo Sanchez-Serrando, organize a series of meetings on environment in this very room. And of course, my partners in this is fellow academician Paul Crutzen, whom I consider to be one of the top pioneers in the area of environment and its impact on human beings. And then Professor Dasgupta, you heard him. And so this meeting, of course, we was co-organized with Chancellor Serrando. He and I have exchanged probably about 1,000 emails in the last 6 months. And Partha Dasgupta and later Peter Raven. So it's sort of a unique meeting in that it's brought in this hall, experts in humanities, social sciences, faith leaders, and political leaders. And our primary focus here is on the health of humans and the health of nature, or as our faith leaders would call, health of all creation. So that's the topic ahead of us. And I want to thank Professor Werner Arber and Partha Dasgupta to set the stage for these discussions on this focus topic. So, of course, we're not organizing this meeting in vacuum. We were standing on the shoulders of 2 giants, WHO and the Lancet Commission, who really started on this path of linking air pollution, climate change, and health, at least over the last 5 to 10 years. So we will hear from the leaders in there, Maria after me, and then Sir Andy Haynes tomorrow. So what I'm going to talk to you about today is this report we published about 3 weeks ago during the UN Climate Week. It was chaired by myself, fellow academician Maria Molina, my colleague at UCSD, and he's a Nobel laureate, along with Paul Crutzen. And then Durwood Zalke is a legal scholar. And we have 33 co-authors. And the co-authors include a group similar to this, humanities, social sciences, and natural scientists. We also had some military experts. Just to come to conclusion, to come to the point, we concluded in this report that climate change is morphing into an existential threat. That's sort of an unusual word to use for natural scientists. So I want to walk you through what are the data which persuaded me to go along with this conclusion. So let me start with air pollution. This is a satellite image with a camera which has the same sensitivity as your eye. So if you're orbiting the Earth, you would see this plume of air pollution. What you see is particles. What you don't see are all the gases which are emitted. So this is the combination of both the poor cooking with firewood and dung and all the industrial technologies. So let's just go into that. We made aircraft measurements inside this plume off of the Bay of Bengal and off of the Arabian Sea. So typically, this is what you see. It's a chemical soup. You make measurements in Italy, or where I come from, San Diego. They will all have all these chemicals, but in different proportions. And I put there for you the various sources. Black carbon, it's what gives the brownish color to this. Biomass, diesel and coal, organics, ammonia, from agriculture, but the hydrogen in the ammonia comes from natural gas. Interesting. And then sulfates, we know it comes from coal, and so on and so forth. So we will hear about several talks how inhaling this impacts our health, causing mortalities, morbidities, etc. So I'm not going to touch on that. And I just want to pick up on the theme Partha talked about. This is an estimate which was just published last year, cost of premature deaths due to ambient air pollution. It is very interesting. The total cost, they call it as a subsidy to the fossil fuel industry, $5 trillion. This is the International Monetary Fund working paper. But just to take a look at the number in India, that's $800 million every year. And if you take Partha's number of 500,000, and then say about 1 million die each year in India, we'll get a more precise number from Jost Lelyfeld or others. You convert that, that comes to $500 billion India is losing every year in its natural capital. Of course, China is close to $1.5 trillion. And the air pollution also impacts ecosystem through acidification of the soil, and it impacts climate in a huge way. I don't have time to get into it. So let me go to the climate topic. So many of you, at least my American colleagues, all know how climate change science is called as junk science or flawed science. I'm just talking about my own insight into this. I helped in '79, NASA launched the first climate satellite. A lot of my work was using that climate satellite, and then moved on to actually what we call field experiments, and where we really go there with aircraft, ships, and satellites. And then last 10 years, I've been using drones. Many call me a super spy. If you're polluting the planet, I know how you're polluting it. But this is the data I use to synthesize my understanding of climate change. I'll tell you how this data led me to the existential threat deduction. Yeah, so now let's switch from air pollution to climate change. Let's start with carbon dioxide, the biggest villain as far as climate change is concerned. As of 2010, we have already emitted 2 trillion tons of CO2. About 950 billion tons is still in the air. Mind you, the sheer weight of that's equal to about 450 billion cars, okay, circling. And that covers the planet like a blanket, and it traps the heat coming from the surface in the air, which would have otherwise escaped to space. It is the blanket effect which warms the planet. Well understood physics, the magnitude is determined by quantum mechanics and laboratory data. So at our current rate, I accounted for the Paris agreement, we would have put the third trillion another 13 years. And we would put the fourth trillion in the next 20 years. And in fact, our chair, John Schellenhuber, pioneered this way of understanding the carbon budget. And our best understanding of climate change is a 50% probability. Each trillion ton would contribute about 0.7 of a degree Celsius. So if you go on the current path, don't do anything beyond Paris Agreement, by 2030, you would have committed the planet to 2-degree warming just from carbon dioxide. There are numerous other pollutant gases which contribute as much as 40%. We call them short-lived climate pollutants, etc. These are technical terms. So let's see what this means. So I want to I normally don't show these things, but because our science is being attacked, how do you judge science? By the prediction it makes, right? So we predicted in 1980 that the global warming, if the theory is right, or if it's valid, we should see the signal by 2000. We did a signal-to-noise analysis, and unfortunately, it was in 2001, the IPCC, team of 1,000 scientists, confirmed we are seeing human-detected warming. And I'm just showing you my work. There were numerous predictions which have been confirmed. Just to cite two more. In 1895, the Nobel laureate Svante Arrhenius predicted that when the planet warms, the warming will be amplified by water vapor. We'll talk about that a little bit later. And that has been proved. And the third, in the 1960s, the Russian climatologist Budiko said a warming would be amplified in the polar regions by the sea ice melting, letting more sun reach the ocean. And that has been proven so many times. So that is why climate scientists, we are worried about this. Our predictions are coming true. And so let's continue on that path. So what is my prediction in this report we use? In the next 30 years, in 15 years from now, we would exceed the threshold for what the United Nations calls dangerous climate change. In 35 years, we have a 50% chance of 2 degrees warming. And myself, Schellenhuber, and others will talk about why these things are dangerous thresholds. But I want to take your attention to another thing in this report. We said that's a 50% probability. What are the 5 to 10% probability? And we concluded we have a 5% probability of witnessing catastrophic changes in just 30 years from now. So how do we assess that catastrophic change? All of this are studies published in the last 5 years. About 3.5 billion exposed to deadly heat, and the 2.4 billion exposed to viruses. That number includes both population and warming. What that study showed is several hundred million living in temperate latitudes would be exposed to these kind of viruses just from climate change. And severe widespread droughts. The key thing I want to emphasize is the velocity of the changes. The speed of the change will be too fast for us to adapt. That is what, in our risk category, we mean by catastrophic. So I want to walk you through some of the data, but, oh, sorry. So let's go beyond 50 years from now. Our science cannot tell us a precise number. All we can give you is probability distribution. It's a complicated curve. Just focus on the red curve, which says, baseline. This is the IPCC's prediction. Normally, people quote 4-degree warming. That you see is a 50% probability central value. If you want to think about 5 to 10% probability, that warming could be as large as 6 degrees. No models have considered this warming beyond 4 degrees. And in fact, Schellenhuber's Institute has done a series of studies on tipping points. So let me go on. Oh, sorry, I'm going the wrong way here. So how do we relate to 5% probability? We lose most people. But 5% probability is a 1 in 20 chance of that plane falling down. None of us would get on that plane with that odds, but we are sending our children and grandchildren on that plane. Think about that. And that's one of the things I learned being in this academy, that you need to think about the human dimensions, and you need to personalize this. You need to think about your children and grandchildren. That's the only way I feel we're going to solve this problem. So let me give you my prediction for 50 to 80 years. We say there's a 5% chance for exposure to existential threat. I'm going to walk you through some of that data, okay? It includes close to 7 billion exposed by the end of the century. We are factoring in the population would be 9 to 10 billion. 20% of species threatened with extinction. Our expert on this, Peter Raven, will talk about this. And we will set the stage for ice-free Earth. Then you're talking about sea level rise of 50 meters or 150 feet or more. So let me, first, this was a study published in this year in Nature. They talked about the probability of heat waves, 40 degrees Celsius, for my American friends here, 104 degrees Fahrenheit, and then 55 degrees heat waves. And there is, you can see that most of the world, there is a 70 to 90% probability of routine heat waves of 104 degrees or 40 degrees. And we go into the deadly heat wave area, it's still the percentage is 40 to 50%. So this was, again, a study which came out just about 5 months ago. They took observed data of all the more heat-related mortality events over the last 50 years and plotted the data when major deaths happen, okay? That when you exceed that red curve, that's considered deadly heat. I just want to point out to you, they measure deadly heat by how outside the skin temperature has to be colder than your core temperature of the body, which is 98 degrees Fahrenheit. I'm sorry to my European colleagues. I feel Fahrenheit, but I think in terms of Celsius. So what they estimated, 74% will be exposed to deadly heat for at least 20 days or more of each year. You will quickly think, oh, I can just stay in my air-conditioned cars. How about all the farm workers? How about all the people who have to, construction workers who have to work outdoors, okay? Now let's talk about one of the inescapable things of temperature increasing. Your soil will lose moisture by evaporation. There is an unbreakable thermodynamic law. Each degree rise in temperature would increase evaporation by 7 to 10%, okay? So they estimated, again, mind you, if you look at IPCC, they show you average of 25 models. I'm focusing on the 5 to 10% probability. These two models, one is the Princeton model, the other is CSIRO from Australia. Look at the areas suffering from moderate to severe drought. Almost everywhere. According to the Princeton model, Californians, we have our president of our Senate here, Senator Kevin De Leon. I'm requesting you to be very friendly to Canadians. They are the ones who will add the water. And Mexico, Central America, according to this model, would suffer some of the worst droughts possible. And now, the most eerie thing of this, I'm showing the Princeton model on the top and showing you the observed data for the drought in 2015. I was shocked by the remarkable similarity. Look at California, look at the Amazon region, look at the Mediterranean. The Mediterranean, I'm sorry to say to my Italian colleagues, doesn't fare very well. And so this study estimated, apparently in 2015, 40% of the land area suffered from severe to extreme drought. And the Princeton model saying that could go to 30 to 45%, almost half. I would like to request Partha Dasgupta to estimate how much this would deplete the natural capital, losing your land. So the other thing, which I consider, in fact, the most major study, which was just published in August 2017, they looked at the drought recovery times of forests, right? We have major drought this year. How long does the forest take to recover? That's based on the carbon uptake. It's measured from the satellite data. What they are finding is that until about 10, 15 years ago, the recovery time was 6 months to 2 years. But some of the recent trend, they're finding it could take almost 45 months to recover from one drought. That's from the Amazon, which suffered a drought in 2010 and 2012. Maybe it's from El Nino, but the evaporation from the soil is from the warming, okay, steady warming. And look at then the future when they're showing you'll have a drought like this almost every few years. That's the right side. So collectively, these are the things which focused this report chaired by Maria Molina, Durwood Zalki, and myself, with 33 others, that this problem is slowly slipping from our hands and becoming an existential threat. And I came to this conclusion, and I wanted to test it out to see if there'll be pushback. So I gave talks at Parthas Institution. They have the Center for Existential Threat. What better place to talk about this than that? And then at Oxford and several UC campuses, so far I've not received any pushback. And in fact, many scientists have told me quietly, Ram, we have come to the same conclusion. So, but again, I'm talking about 5–10% probabilities, okay? So let's look at the second issue, climate justice, which I think is going to be discussed in this. I'm showing the contribution of the various population to the carbon pollution. The poorest 3 billion, which I'm calling the bottom 3 billion, their contribution is somewhere between 5 to 7%. The wealthiest 1 billion is contributing 50%. As of 2009. And the future projection by environmental economists, we will go from 27 to 43, but 60% of the increase is coming from the wealthy 1 billion still. We are still putting the carbon out there, okay? And the poorest 3 billion are just stuck where they are. This is by the Princeton group data we used. So let me just wrap it up. Let's look at the historical past. It's just my hand-stretched drawing I do in my class. Start from 20,000 years ago when we were in an ice age, okay? We recovered from that ice age about 11,500 years ago and went to Holocene, stable climate, which permitted agricultural revolution, etc. Then the Anthropocene starts. This thinking about this Anthropocene was again initiated by our academician Paul Crutzen. We are already now, or in about 10 years from now, will have the climate which we witnessed 130,000 years ago, when the sea level was 6 meters. But it could take a century to get there, but we already set the boundary condition. And by the later part of this century, which is 50, 60 years from now, if we reach 4 to 5 degrees, that would be the climate we witnessed 30 million years ago, when the Earth was completely ice-free. So that is kind of the regime we are gradually slipping into in 1 or 2 generations. I wanted to talk to you just briefly. Let's look at the last 2,500 years in the Holocene. I was visiting my neighbor here, Professor Yenze Lee, and he arranged a visit for me to visit this Divine Gardens in Taiwan, one of the beautiful mountains. Look at the birth date of that tree, 551 BC, the same year Confucius was born. And Buddha was 12 years old. And this tree has witnessed birth of Socrates 250 years later, birth of Christ. Is that because it had a stable climate, no invasive species? And if you look at the next 100 years, that tree is going to see the change of the next 30 million years. I don't think it has a chance to survive. So that's what we are doing to our children and grandchildren and generations to be born. So what I'm proposing is that we consider fossil fuels and solid biomass burning as outdated technologies. They have served us tremendously well. I wouldn't be here without fossil fuels. I would be stuck in here. I shouldn't say I'd be stuck in India. I'm just saying I would be in the village where I was born. So I'm not forgetting the history here, but still the time has come. And what we are trying to propose in this declaration, held by many here, is that we consider these fuels are emitting chemicals that are hazardous to human beings, that are making the soil acidic, making the global oceans acidic, hazardous to many ecosystems, and basically hazardous to all species. Peter Raven would tell you about that. And I think tomorrow I'm going to talk about how to go from the red to the green. This may be challenged, but I think our own in this report, it's not too late to avoid catastrophic consequences. I believe Professor Schellenhuber's group has papers showing that we still have time and we can bend the curve and shift to the green path. I'll talk about this tomorrow. And I want to conclude to our Chancellor, Marcella Serrando, Sir Partha Dasgupta, Peter Raven. It was an honor to work with them in this meeting. I think thanks also to this incredible team of very few people in this academy who make all this happen. I also want to thank our co-sponsors from this World Health Organization, UCSD Institute of Medical Health, and Miraglo Foundation. And thank you all for accepting our invitation.